In high voltage environments, having the right safety gear is a non-negotiable. The difference between a minor accident and a life-threatening one can often come down to following the protocols that are established and to using the correct personal protective equipment. In this fourth module, we will focus on the safety equipment and the protocols of high voltage systems. This is our roadmap for this module on safety equipments and protocols. We will start then by presenting the personal protective equipment. This will include a description of the different types of gloves or clothing protections, eye protections, footwear, tools, and in general all the items that we have to wear to be able to be protected. Then we will discuss the testing and validation, how to make sure that we meet the required standards and that the equipment that we are using it remains in good condition. Then we will review the emergency protocols, understand what are the correct steps to take that we have to take if something goes wrong, and finally some common mistakes. So we will highlight those errors or misconceptions that will help you to avoid in real world scenarios. So let's begin by looking at the personal protective equipment that is going to be the front line of the set of defense for everyone that is going to be working around high voltage systems. When we talk about electric vehicle safety, the PPE or personal protective equipment is going to be a crucial piece in this puzzle. As we will explore and as we have discussed also before, the high voltage components have a unique risk of electric shock, arc flash, chemical exposure from the battery, and so on. And the equipment is a nice to have. It's often legally required by the different standards and international organizations, but even if it were not required, it is nice to have for us to feel protected and to be protected. As we move through the content, I would recommend you to keep in mind three main points. The first one is the assess the task. There are different jobs and each job will require different levels of the equipment that we are using. We will see that it will go depending on the voltage of the environment where we are using it and how risky is the task that we have to do. In each of the cases we have to assess the task and to select the current level of protections. The second one is to select the right protective equipment. So to know when we need gloves, when we need clothing, when we need eye protection, footwear, the tools, and how all of those should be rated for the voltage and the potential hazard that we will be facing. And the last one is to always inspect before we use. So even the best equipment we have, even if we use the best equipment, it will not protect you if it is already damaged or if it has expired. So we also always have to inspect before use to be sure that it stays in good condition. So let's start by looking at one of the most relevant pieces, that is going to be the insulating gloves. The gloves are often the first line that we have of defense, since we are usually using our hands, and this is the directly handling the electrical components. In general, when we are dealing with high voltage systems, like for instance the EV batteries or in general power electronics, the gloves are going to be essential. There are two main purposes that they serve. This dual protection is that it has protection for electrical and mechanical hazards. The gloves will prevent the current from flowing through our body if we accidentally touch, for instance, or come close to a live part. And additionally, Many gloves also have protection against, for instance, cuts, punctures, abrasion, so they are providing as well a mechanical protection for us. Besides of that, the insulated gloves also help us to protect from arc flash or from the electrical shock, and also from the thermal radiation and all the debris that is generated during the arc flash. We can think of them as a very important barrier against the burns, and if our hands injuries, this can be devastated, so we need to rely on very good gloves. And the last of the purposes of the gloves is the thermal resistance. We have some gloves that are usually labeled, for instance, as category C, that are gonna that can help us to protect our hands in even extreme cold conditions and cold environments. And this is gonna be very helpful if, for instance, you are working on a high voltage systems outdoor or in a very cold facility, and having those gloves not only protect us from the electric shock, but also keeps our hands functional and safe. Besides of the purposes, when we are talking about the safety equipment, usually we have to align with different compliance and standards. So here, for instance, there are two of the standards that come into play. We have the IEC 60903. This one particularly defines the requirements for insulating gloves, covering, for instance, different voltage classes from 00 to 4. We will explain that later. And also environmental resistance, like for instance resistance to ozone, to acid, to oil, and so on. So we have to check that the gloves that we are using are certified according to this standard, to ensure that they are going to be aligned to the different levels of high voltage work that we will be executing. Also, according to this standard, we have the double triangle symbol. This symbol is going to be marked on the gloves and indicates if it is suitable or not for live work. It means, in other words, if these gloves meet the design and the testing requirements for working on an energized equipment, or if the equipment has to be insulated to be working on that. And finally, in the United States, we have the ASTM D120, that this standards governs how the rubber insulating gloves are going to be manufactured and how they have to be tested. So with this standard, we cover the voltage resistance, the physical durability, and the aging of the gloves. And when we are meeting these standards, it means that the gloves provide a very high assurance of safety in many demanding electrical and mechanical environments. In general, we have two primary types of gloves for high voltage scenarios. On the one side, we have the latex insulating gloves. These types of gloves are made from natural rubber or latex, and they are very good for the electrical insulations because they are excellent at the electrics, are lightweight, they are very flexible, and it help us to maneuver easily when wearing the gloves. But typically we need leather protectors over them to be sure that we will not be, if we want to have any additional mechanical protection. So if we want to safeguard against cuts or punctures, we need to add an extra layer. On the other side, we have then the composite insulating gloves. In these cases, we have blends of rubber with other synthetic materials, and the reason for having that combination is to have the dual protection, to have electrical and mechanical protection. So the advantage of this is that often we don't need external layers of leather gloves because these gloves are already cut resistant, are way much durable. Also, they are more resistant in critical environmental places, like for instance, they can be resistant to ozone, to the UV, to chemicals, and so on. So the choice between these two types of gloves will depend on the task that we have to do, on the environment, and also on how much mechanical resistance we will need. For very delicate, detailed, and fine work, we prefer to be working with flexibility. Maybe in that case, the latex gloves are the best option. But for instance, when we are having heavy tasks, in that case, the composite gloves might be way more robust. As was mentioned, the gloves are going to be classified according to the voltage rating, and they are growing from class 00, that are the lowest voltage rating, and it goes up to class 4, that is very high voltage rating. For electric vehicles, usually between class 0 and class 1 are good enough. These are commonly used in some specialized cases, like for instance in the working with the batteries and so on. But this is what usually we use. If you are dealing with a class 0 or a class 00 gloves, in these cases we have to do a primary visual inspection of the gloves, and usually we also have to do the air inflation test. That means only to inflate the glove and to see that there are not any leakages of the air and it remains in good condition. If we have class 1, class 2, 3, or 4 gloves, in those cases, usually we have to do regular dielectric testing, and it is mandatory in many standards. So often every 6 months we have to be sure that the gloves are in good condition after doing the dielectric test. Additionally, of the voltage rating, the gloves come also with different resistance categories. That is these letters over here. So the category A stands for the gloves that are resistant to acids. Category H is when it is oil resistant. Z is when there is ozone resistant, and so on. For higher class gloves, we usually again it's to do this periodic testing, and as general rule, if the glove is punctuated or if it loses insulation properties, or if we see that is, for instance, a scrap, in those cases when we notice any damage, we do not use that gloves. Also, many people tend to try to repair the gloves, but this is not recommended neither. What we have to do is to replace them and to ensure that we are wearing reliable protections. Now let's continue and let's move to the clothing protection. So specifically for the arc flash suits and for the workwear that we need to use. An arc flash, as we have exposed before, is the sudden release of electrical energy that goes through the air, and it can produce very, very high temperatures that are even similar to the temperature of the sun's surface. And also this release of energy can send out debris, metal parts, and shock waves. So when we are trying to protect against arc flashes, we have this type of suits that are designed to shield somehow, or to put a shield over us from the extreme heat and the thermal radiation that the arc flash will be generated. Also, It will provide some flame resistance, meaning that they won't ignite or they will not burn once that the ignition source is gone, and also they mitigate the intensity of the injuries that are caused by the metal splashes and all the elements that are going to be released during the arc flash. We have different standards again for defining the protective clothing, but according to the NFPA 70E, we can classify the suits in 4 categories, from category 1 to category 4, and each of these ones is intended to be used for a maximum amount of energy that is released, that is measured in cals per square centimeter. So the first category is going to be the basic protection. In this case, usually it is enough to wear long-shelved arc-rated shirts and pants, and to put some additional protective equipment, like for instance safe glasses and the gloves. The second category, it will require a little bit additional arc-rated gears. So in this case, for instance, we will be wearing a face shield and also an arc flash hood to protect ourselves. Then in the third category and in the fourth category, we have the more intensive gear. In those cases, as you can see, it will be required to wear these full arc flash suits, the hoods, and also multiple layers of protection. And the idea here is that each protection will outline the minimum R rating that should have to protect against the hazard at that level, and we have to check in each case in our workspace the electrical hazard to analyze and to see what of these categories is relevant for our tasks. The arc flash suits are not only, or it is like mistaken that they are only required in traditional power plants and utility places where there is very high voltage systems, and that it is electrical work being performed. Right now, with the growth of the electric vehicles and the possibility of high voltage incidents being expanded, we need to wear arc flash suits in other applications. So for instance, when we are having battery maintenance of the electric vehicles, in many of these tasks we might require the suits. Also, other applications are, for instance, power distribution and the grid maintenance during the substations, or when we are performing any work with transformer. Those cases are also required to have the flash suits. The switchgear operations as well, and in industrial electrical work as well. In any of these applications, every time that we are not sure whether the suit is required or not, we have to consult the risk assessment, and we need to rely on the recommendations and the standards specific for our work. To ensure that arc flash and flame resistant clothing does its job, we usually have the regulations and the standards that comes into play. We have already discussed some of these in the past, but here there is a summary of what are the documents and what each of these standards, what information it will be shared in each of these standards. So first we have the NFPA 70E. This is a key resource for, in general, all the electrical safety in workspace. We have this another standard, the ASTM F1506, that covers the performance and the testing of the flame-resistant textiles and the clothing. There is the EX61482, that is an international standard that addresses the protective clothing against thermal hazards and in the case of electric arcs. And there is the OSHA 1910. This is particular for the US, and these standards outline the personal protective equipment requirements specifically for electrical workers. So the documentation in each of these standards details everything from the fabric tiers, the strength, the arc thermal performance, and also all the certifications that are needed to meet or to exceed the protection that is needed in the high voltage environments. So far we have addressed the globes, the arc flash clothing, and next let's discuss the eye protection. So the eye protection is one of the most overlooked areas in the EV safety. Just like the arc flashes can burn the skin, they can also severely harm our eyes. So there is very important to select the right protection, from basic goggles to full arc flash hoods. We need to have the good eye protection. So as mentioned, the electric arcs can emit a very intense light, and including high amounts of ultraviolet and also infrared radiation. All of those can damage and compromise our vision. So on top of that, we have also the debris that is being expelled from the arc flash, and this can cause eye injuries, and even the fire that is generated can damage our eyes. So eye protection in high voltage work usually is mandatory and will fall in 3 categories. We have safety goggles that are good for general tasks like shielding your eyes from the debris that is generated. Then we have the face shields. Those provide enhanced protection against the arcs and the debris. And finally we have the arc flash hoods that offer the maximum coverage and the thermal protection for high energy work. No matter which type you choose, we have to in general ensure that they are going to be rated for impact resistance, and if required, they are going to be also rated for arc flash scenarios. Similar as we did with the globes, we have to regularly check that they are not scratched, that they are not damaged, since that can compromise the lenses. It can reduce our visibility and also reduces the protection itself. So I will go fast through each of these ones. One of the most basic ones is this hard hat with safety goggles. This is a straightforward solution for many EV manufacturing and maintenance tasks. The hard hat will give us protection in our head for any falling objects, like for instance screws or anything that can fall. And on the other side, the goggles will seal our face against the dust, the sparks, and the chemical splashes, and it will give us a protection. The next protective eye protection will be a hard hat with face shield. This will extend a little bit the coverage from the forehead to down to our chin, and this is especially relevant when there is a chance of, for instance, an electric arc or flying particles. So many face shields are made from polycarbonate or similar materials that will withstand high heat and also impact. So they are an ideal when we are working very close to the battery packs, to the bus bars, or to very high voltage components that could cause an arc. This is good equipment to use. And the last one is the arc flash hood. So this is the gold standard for eye and for face protection. It is the most hazardous electrical, and it is used in the most hazardous electrical work. It offers a full head enclosure, and it is built with flame-resistant materials that can handle very high thermal energy. In general, this is going to be used for working with energized high voltage equipment when we know that there is a high probability of risk with the battery that could cause an arc flash, and this can be catastrophic. In those scenarios, we use this type of arc flash hoods. So far we have covered the gloves, the clothing, and the eye and face protection. Now let's address the footwear. So footwear, many times it is overlooked, and this is a mistake because the footwear serves several purposes. One of the most important ones is the electrical insulation. When we are using specialized boots, this helps us to prevent electrical current that is going to be traveling through our body, and that will be directed to the ground by means of our foot. Also, footwear provides impact protection. A dropped tool or a battery model can cause foot injuries, and if we are not wearing reinforced boots, that might cause problem and hurt us severely. Also, there are many workspaces, for instance, mechanical workspaces in the automotive sector and so on, that will deal with oil, with liquids, with coolants and so on. In those cases, the footwear will provide us slight resistance and give us an additional traction to prevent us from falling easily. So when we think about the footwear, we have to think of it as another layer of safety in our systems. In general, if the gloves protect our hands, the footwear does the same for our feet and will ensure that we are grounded in a safe way and literally. And this is going to be literally very important and not only figuratively. There are different types and different features in our footwear. One of those is to have these insulated boots. These insulated boots are designed for the tasks that involve direct contact or proximity to live electric parts. They are used especially because of their high dielectric materials that they are made of, and those electric materials have the function to stop the current flow. They are recommended for high voltage battery maintenance, power electronic work, and any scenario in which we have the potential shock hazard through the floor. The materials that we use here usually are thick rubber soles. Also, these materials are tested for specific voltage ratings similar to the gloves, and they often come with very bright colors like orange or yellow in order to have a quick identification. Insulated boots are needed to have regular inspections to validate that they are not cracked, that they are not punctures, that they are not worn, that the soles are in good shape. So the ability to have that insulation is not compromised. Another type of features in our boots is, for instance, the steel toe boots. These might not be specifically made for electrical insulation, but they are often critical when we are needing a protection for impact or for compression, for instance. That is very important in the EV assembly lines or in the garages when we are doing the maintenance of the vehicles. So it is used in manufacturing floors, in heavy maintenance tasks. Also, the reinforced steel will protect us against any dropped objects, and in combo we can also have protection for electric hazards if we if we use the electric materials as well. And also there are specific boots for the anti-slip. In many EV workshops, as was mentioned, we have the chemicals like the coolants or the battery electrolytes that could spill, and in those cases this type of boots will make us or will help us to maintain a firm footing. These are going to be boots that are waterproof, that are going to be chemical resistant. They are often made of specialized coatings that repel the liquids, and that makes them very good keeping or avoiding us from slipping. And in general, it is a good practice to have a rotation of footwear. So for instance, insulated boots for when we are doing high voltage tasks, additionally maybe another pair for anti-slips, or to have the protection on the steel toe boots when we are doing mechanical work or when we are doing messy works, and to use each pair of boots according to the task that we are going to perform. In this way we ensure that we always match the footwear to the specific hazard that we are handling. And the next discussion we will have is then regarding the tools. Even if we have the right protective equipment, using non-insulated screwdrivers when we are working with live circuits is going to be very important to avoid any hazard. Let's see and let's detail what are those insulated tools, and how these insulated tools will add another layer of safety to our routine. So insulated tools are specifically engineered to reduce the risk of electric shock. So we have to think of them as the globes for our tools, and the shelves that will cover our tools in such a way that it is safety for us to handle them. When we are having these insulated tools, we have to discuss or to talk about the high dielectric insulations that they usually have. These tools are covered by rubber or plastic materials that are tested up to certain voltage ratings, and usually the tools are labeled according to those ratings. For instance, 1000 volts AC or 1500 volts DC, and they have to be rated for the related voltage. Also, they are characterized by having bright colors. These tools usually have red, orange, or yellow colors in such a way that we can quickly differentiate them from the regular tools, and they also have a specific marking, so clear voltage and standard compliance labels, and the ratings of the voltage as well has to be clearly readable. Before using these tools on high voltage systems, always we have to check again that they are not damaged. We have to check that there are not cracks in the insulation, or that there are wear spots that can compromise their protective properties. These are some of the common insulated tools that we may have seen already. On the one side, we may work with screwdrivers that are used for fastening or for loosening screws under high voltage conditions. We have also the pliers and the wire cutters that are used to clip or to cut potentially live wires without having the risk of shock. And also we have the wrenches that are essential for tightening, for instance, the bus bars of the battery terminal safety. When we are selecting these tools, we have to make sure that they are rated for the correct voltage, and we will also have to be sure that they meet the international safety standards. In general, all these tools have to be kept clean, stored properly. Usually they come with a case or a specific insulated enclosure that we have to keep, and we should never modify the tools. We have to use them as they come in such a way that we respect the design and the insulation that they have. All of this to ensure the safety but also the longevity of the tool set that we are using. And finally, let's talk about the respiratory protection. In some specific, not all, but in some specific high voltage maintenance scenarios, we may be exposed to gases, to chemicals, or to dust. In those cases, the respiratory protections comes in. We will explore here what is necessary and what are the different types of respiratory protection, from the simple dust mask to powered air purifying respirators that are needed in very specific tasks. So let's start then to understand when should this respiratory protection be used. In general, respiratory hazards in electric vehicles environments may come from chemicals spills. A battery that is malfunctioning can generate fumes, or there might be also another types of airborne contamination, like for instance dust, gases, electrolyte leakages, and so on. So according to the OSHA organization, we will need the respiratory protection in specific cases, like for instance when the oxygen levels are very low, or when we are uncertain about having the enough oxygen level. Also, when we are going to be exposed to harmful levels of any hazardous gases or vapors. And the last one is that we need to use respiratory protection when we have dust or particles in the air that could harm our respiratory system. In practice, that means that if you are opening a battery pack that might release, for instance, toxic vapors, or we are working in a very poorly ventilated rooms with chemicals and so on, in those scenarios we should be wearing the appropriate respiratory equipment, and let's see what are the different types for those. So there are, as mentioned, there are different types of respiratory equipment. One is the air purifying respirators, or the APRs. These respirators will filter out the contaminants from the surrounding air, and they will come into different forms. We have from the most basic ones, that is the filtering face piece, that is like a dust mask, and this is a very basic protection for not hazardous dust, is what we can this mask we can easily acquire anywhere, and it is helping us or entry point in the protection. In the middle we also have this half mask elastomeric respirator, and this will offer a tight seal and can also filter vapors or particles that are going to be in the air. And finally we have a full face piece elastomeric respirator, and this full face piece will provide both the respiratory and the eye protection. This mask, all of those must be fitted tested to ensure that the air is airtight seal, and if your task involves, for instance, toxic fumes, chemical vapors, or any others, these different protections will help us to prevent or to help you protecting your lungs as well to avoid exposure to specific contaminants. When we are dealing with very challenging conditions, in those cases we might require powered air purifying respirators. This is a step up in what we have to use. In those cases, this respirator has a battery-powered blower that will push the air through certain filters into the hood, and in such a way it will clean the air that we are using to breathe. There are different types. There is the first type that is loose-fitting power air purifying respirator, and there is also a hooded power air purifying respirator. The latter can reach higher protection factors, and it is ideal for tasks when we are having very toxic chemicals and when we have also heavy particle exposures in a manufacturing process, for instance. And on top of this, there is another type of respiratory protective material that is gonna be the atmosphere supplying. These provide clean air from a completely external source. In those cases, we are not cleaning the air, but we are using the air that is coming from these external sources. We still have three different types of equipment that we can use. We have a self-contained breathing apparatus that will carry its own air supply, and this is, for instance, often used by the firefighters. Also, we have this second one that is a supplied air aspirator. In those cases, we connect to a remote air source, and this is very suitable, for instance, for abrasive blazing or for high toxin areas. And the last one is when we have auxiliary escape bottles that will provide a short burst of breathe air in if the main supply fails. In those cases, we can have an auxiliary escape bottle to have another layer of protection. All of these systems are used in situations where the air contaminants are extremely dangerous or the oxygen is going to be critically low. Fit testing is again mandatory, and also in those cases we required special training on how to use them and how to maintain the gear in good shape, and on what is the everyday requirements that we need to know for using this equipment. So up to here we have covered already all the different personal protective equipment, and we know what are the different types of gloves, face mask, footwear, glasses, and respiratory equipment that we have to select according to the task that we are executing.